Hello and welcome to the Mastercam 2021 Lathe programming session. So in the previous session we have covered facing toolpath using canned cycle and general cycle. So in this session I will show you that how we can create the OD turning using general cycle and canned cycle. So let's start. So we'll go to the toolpath tab and here you will get first option, that is rough OD turning. So I will select on that, and now here you will get the selection method of your wireframe. So here you can say partial selection. So here you can define the first chain. So we'll select, this is the first chain. So it's showing some errors, so I will select from this face and I will minimize it, and I will go to the last chain. The last chain is this one. Perfect. So I will select on that, and here I will say okay. The next one is we have to define the tool, which tool we have to use. So we can select that from here. So we will use this tool and we will check the insert. So this is DNMG 1506.8 insert, and here you can change the corner radius. I will say okay, and now I will go to the tool number. I will say tool number 2 and feed rate as per the tool trade, and material hardness we can define here. I will say 0.1, and here we can define the spindle speed, that is RPM. I can say 1500. No, I will give minimum 200 and maximum 1200. And here I will use CSS, that is constant surface speed, and here we can change the home position. I will select user define, select from this point and then say okay. And the next we'll go to the rough parameter, and here we have to define the value. So we can define that value from here. So first we have to give depth of cut. This is the depth of cut. So we are using a 0.8 insert, right? So we'll give minimum 1 mm of cut, and here you can give minimum depth, minimum cut depth, that will be 0.01. Stock to leave in X means you can leave the stock for finishing purpose. So you can give the value whatever you need, 0.2, and here we can define the stock to leave in Z. So I will give 0.1 stock in Z axis, and here we can define the entry amount. This is the entry amount which we can define for clearance purpose for shape position, right? So our tool will start 1 mm above, 1 mm far from this face. So we can give minimum 1 mm or 0.5, whatever you need you can apply there, 0.5. okay, all right. So here you can give the exit amount in the last passes. So you can apply that as per your choice. So I will give minimum 2 mm exit amount in the left side. So I will give 2 mm of exit amount, and here you can select the compensation type. So if you want where, you can select that from here. If you want computer, you can select that from here, and here compensation direction will be right side, and roll cutter around corners. This is very useful. So if you want to remove all the sharp edges, so you can say roll cutter around corners, you can say all. So it will make it will remove the sharp edges automatically. And if you want to make it sharp, you can say sharp. And if you don't want to use this, you can say none. So this toolpath will follow your chain geometry. It will follow the complete this chain geometry, and it will create the passes as per this geometry shape. So next here you can see this is the lead in out. This is used for entry exit. So you can give the entry exit value. So if you want to do entry in 180 degree, so you can give that value here, and you can give the entry length here 1 mm, and here you can give lead out. So if you want to exit in 45 degree, so if you give 0 degree, then there may be chances of your tool will touch this part. So it will give the bad finish. So we will use 45 degree exit method, and here we can give the length 1 mm during exit, and here we can say okay. And here this is the plunge parameter. This is also very useful. So you can see if we will use this plunge cutting method, then our tool will not plunge in this type of grooves and undercuts. So if there will be any groove or undercut, your tool will not plunge. And if you want to plunge your tool in the grooves, so you can use all these methods. So all the methods are available, so you can select that if you want to plunge in the groove. So I don't want to plunge in the groove, so I will select none, and then I will select okay. Fine. Here filter option is there, so you can give the minimum tolerance to get the better finish and to maintain the tolerances. So these are the things which we have used. And here you will get stock recognition if you are using any casting type of material. So you can use this remaining stock. So simply you have to create stock as per the casting part, and you can give the reference. You can say follow the remaining stock. So this toolpath will create only rest roughing toolpath. So that will be very useful. So here we don't have to use, so I will say disable stock recognition, and then I will say okay. So you can see automatic toolpath has been created, and you can see this is groove type of shape. So that's why our tool leave this stock for rest roughing purpose. So we can use button type of tools to remove this material, or we can use VNMG insert to remove this material. Okay, all right. So I will do the back plot, and I will select on that, and I will say play. So the back plot is going on. That blue color is toolpath, and that yellow color is retraction. That is rapid movement for retraction. So it will remove the possible area material. Right. So as you can see, if we will use this tool for this area, then our tool will collide with this material, because clearance is not enough as per this curvature. So this toolpath is also gauges free. Okay. So next we will use PNMG insert to remove this material. So same things, we will go to the roughing tool path and we'll select boundary from this point to this point, and here I will say OK. And now I will select that. If we will use this insert, then that will be not possible to remove this material. So we need to use some button type of inserts to remove that material, or we can use the right hand tool to remove that material. So that will be also possible. We can use this tool to remove that material. So we can try that also, but I will show you. Okay, let's try this one. So I will close it, and I will say no. I will go to the roughing tool path. But if we will use that tool, right hand tool, so our holder will plunge here. So that will be also risky, and we can't use grooving tool path. So simply I will show you one more option, that is dynamic roughing. Dynamic roughing is also very useful to remove this kind of material very fastly using button tool, or we can use pattern repeat option also using button tool. So first I will show you that how we can use this dynamic roughing. So simply I will select chain from here and chain from here. This is the last one, and I will say OK. And I will find out the insert, button tool insert. So you can see this one, not that one, this one is the button tool. So I will do the double click, and here you will get the history of that insert. So this is round insert, and here we can customize the insert diameter. So we'll use 5 mm of insert. Okay, and we'll give the tool number, that will be third number, and feed rate 0.1, RPM we can give 1200, and we'll use RPM. And we'll go to the dynamic rough parameter, and here we can select that. Here we can give 50% step over. So this is the step over. It will create first pass. If we are using a 5 mm insert, so it will take 2.5 mm of cut in every passes, because we are using 50% of the tool diameter, insert diameter. So that will be 2.5, and minimum tool path radius will be also 2.5. If you want some a smaller cut, so we can give 1 mm of depth of cut. And here tool path radius will use same as per the insert, and stock to leave in X, that will be 0.2, and stock to leave in set we can give 0.2. Okay, fine. So now I will say OK. So the tool path is generating. Okay, fantastic, it's looking good. So as you can see, this is the complete dynamic roughing tool path to remove this kind of material very fastly. So I will do the back plot with the same tool. So I will play it. Let me check where it is. Okay, so we forgot to change the entry exit value. So I will go to the toolpath parameter, and here I will say entry user defined, select from this face. Okay, and then say OK. Fantastic. So I will do the back plot. So as you can see, we can remove this material very fastly by using this button tool insert. Good. Okay, so now I will show you the actual verification, but before that I will show you the kind rough or returning also. So I will select that kind rough, and here I can select the first chain and I will minimize it, and now I will select the last chain. Okay, so I will say okay, and here I will select the same tool, and here same tool number, same feed rate, same RPM, and kind of parameter. So if you will create toolpath using this kind of parameter, so you will get editable cycles. You can give the clearance 1 mm, clearance in Z, that will be 1 mm, depth of cut 0.8, exit length 0.2, stock to leave in X 0.1, 0.2, and stock to leave in 0.2 in X and 0.1 in Z, and then say O returning, and then say OK. So as you can see, this is the tool path which we have created using this tool. So as you can see, in this tool path, this tool is covering all this area, so we can use right hand tool to remove this material. So we don't need to use this dynamic roughing and button tool. So that is also possible. Perfect. So we can remove this material by using right hand tool. Okay, so this is scanned cycle toolpath. So let me check the entry exit. Okay, fantastic. So next I will show you the simulation. Before that, let me save this file. I will select all the toolpath and I will go to the verify tab. So the next window is opening. Okay, fantastic. So I will go to the isometric view, and here I will say backplot. This is the facing toolpath. I will stop it, and here I will go to the verify tab and I will say color loop. So you will get different color with the different toolpath. So that will be also very easy to understand. So as you can see, this is the dynamic roughing going on using button tool. It's very fast. And this one is the last one is OD turning toolpath using canned cycle. So that is moving in air because there is no material. It will remove these materials. Right. As you can see, your tool will not plunge, your tool will not collide with this part. Perfect. So we have covered OD turning toolpath using general cycle and OD turning toolpath using canned cycle, and also we have covered dynamic roughing toolpath also. So this may help you to remove the large material from the stock. All right.